Canadian scientists, University of Washington scientists, NOAA fisheries, people that I've worked with over the years, past 30 years, looking at the question of density dependence and competition among salmon and other marine species in the ocean over the past 30 years. So I'll start this presentation just with a brief overview of hatchery production. And most of my talk will involve Pacific salmon and both returning to both Asia and North America. So throughout the North Pacific. In recent years, up to 5.5 billion hatchery salmon are released into the North Pacific each year. And of these, about 1.5 billion are pink salmon. Most of the pink salmon are released from Prince William Sound and Kodiak. If you look at total biomass of salmon in the North Pacific, about 40% of the adult and immature salmon biomass in the ocean are hatchery origin. This spans a 25-year time period. And most of these hatchery salmon are from chum salmon released in Japan, but also significant releases of hatchery chum in Southeast Alaska and Russia. About 28% of the adults returning are hatchery origin. So a big question that scientists have asked for many years is whether or not do salmon compete for salmon or for prey in the ocean, leading to reduced growth and survival. When hatchery production really started to ramp up in the 1970s and 80s, a lot of the hatchery managers thought that the capacity of the ocean to support additional hatchery fish was unlimited. But now, as I'll show you some evidence in a bit, we know that's not true. And the question is, if there is competition for food in the ocean, should hatcheries release up to 5.5 billion salmon or even more hatchery fish each year? So the analysis that I will present primarily stems with pink salmon. And the reason for that is that pinks are sort of an ideal species to test this competition hypothesis because they're very abundant, as I'll show you shortly, and they have a very distinct biennial pattern of abundance. They typically are very abundant in odd-numbered years in most regions, not all, and low abundance in even-numbered years. And this biennial pattern provides a way to look at how they impact each of the other species of salmon and other marine species, because physical oceanography, for example, can't explain these biennial patterns. So this is a chart just to give you an overview of hatchery production. Numbers of adult salmon returning from the North Pacific, but again, both Asia and North America. The bars, the green and red bars are wild sockeye and chum salmon, the red being sockeye, of course. And just to put it in perspective, this black line here is adult hatchery pink chum and sockeye. There's relatively few hatchery sockeye. Most of this black bar is related to chum salmon and pink salmon coming back. And you can see it's, the combined abundance of these hatchery fish greatly exceeds the individual abundances of wild sockeye and chum salmon. And I should mention a lot of these data that I'm presenting to you here today are from this paper that Jim Irvine and I published in 2018. In that publication, which is available online or from me if you want it, also includes all the data going back to 1925 on wild salmon production and hatchery salmon production. So I'm not going to talk about the genetic impacts of hatchery fish spawning with wild salmon in streams, but it's a very important issue. But I will just read this quote from the most recent Hatchery Scientific Review Group report that came out in 2020, the HSRG was created by the US Congress back in year 2000 to help reform, improve the management of hatcheries in the Pacific Northwest. It wasn't there to suggest closing down hatcheries. It was there to make improvements to the management of those hatcheries. They concluded, and I quote here, from a science and precautionary perspective, the HSRG recommends that the proportion of hatchery fish on the spawning grounds be zero, or at least near zero, in regions that are relatively pristine. In other words, best management practices in pristine regions should ensure that relatively few hatchery origin salmon spawn in the wild. Of course, this is directed towards regions such as Alaska, where your rivers and land is largely pristine, as well as many areas of Russia. So now I'll begin the part with pink salmon, which is a key tool to looking at this competition hypothesis. And pink salmon are just incredibly abundant, and their abundance has grown tremendously since the 1976, 1977 ocean regime shift that impacted many marine species in the North Pacific Ocean. This chart shows salmon abundance, that's catch plus escapement, from 1925 through 2019. And the bars represent the green or chum salmon, the red again are sockeye, and then the larger pink bars are pink salmon. As you can see, salmon production, we've never had more salmon returning from the North Pacific Ocean than what we've seen in the past decade. Roughly 950 million salmon. Again, overall, these years, roughly 70% of those salmon are pink salmon. You guys, I'm sure, are interested in Chinook, coho, and steelhead, but their combined biomass in the commercial catch is actually less than 3% of the total biomass of pink, chum, sockeye, plus Chinook, coho, and steelhead. In other words, the pink, sockeye, and chum dominate the numbers of Pacific salmon returning from the North Pacific. This chart just breaks out the pink salmon abundance record from 1925 to present. What I want to highlight here is just the phenomenal abundance of hatchery plus wild pink salmon returning in recent years, shown way over here, but really highlight the really unusual abundance that occurred in 2018 and 2019. Usually we see this strong biannual pattern with relatively high abundance in odd numbered years and lower abundance in even numbered years. But in 18, there was a record number of pink salmon that returned from the North Pacific, mostly returning to Russia. On average, there was 670 million pink salmon in these 2 years. Just phenomenal. They represented 74% of all salmon. This is the largest by far back-to-back year on record. Hatchery pink salmon represent about 82 million out of the pink salmon that are shown here during this recent 10-year period. That might not, when you're looking at the total wild pink salmon production, that might not seem like a lot, 82 million, but that's much greater than the production of wild chum salmon, and it's about equal to the wild production of sockeye salmon. So it's a significant number of hatchery pink salmon. Well, moving on to 2020, I'm sure some of you have experienced this decline, especially a decline in Chinook. But in 2020, following this record abundance of pink salmon in 2018 and 19, we saw a record decline, a collapse in the commercial harvest of all species of salmon in both North America and Asia. This shows that on average, there was approximately 187 million fewer salmon caught in the commercial fisheries in 2020 compared to the previous 10-year time period, 2010 to 2019. And so these bars are all relative production relative to the previous 10 years, going back to 1930 or so. But in 2020, it was a significant decline compared to what was expected in the past 10 years or so. If we break this down by species, we see that Chinook salmon commercial harvest was the lowest since 1925 in 2020. It experienced a 54% reduction in commercial harvest relative to the previous 10 years. Chum salmon declined 42% relative to the previous 10 years. Pink salmon also declined in 2020, 40%. One area that did increase, which was interesting to me anyways, is Norton Sound in this time period. Coho declined 27%, and sockeye salmon only declined 10%, but that include Bristol Bay, which was, as you probably know, quite robust in recent years. If you remove Bristol Bay from this calculation, there's a 44% decline in sockeye in all other populations. So we presented that information to the North Pacific Anadromous Fish Commission annual meeting last May, and we raised the question as to whether that 2018-2019 super high abundance of pink salmon back-to-back years might have caused a tipping point, leading to continued low production of some of these salmon species, along with more frequent marine heat waves that we've been seeing. So here's an extension. We have preliminary data for 2020 or 2021. It indicates that there was a resurgence overall in abundance in 2021, but that stems almost entirely due to a record harvest of pink salmon in 2021. Roughly 515 million pink salmon were harvested in 2021, represented about 81% of all commercial catch. Plus, there was a record abundance of Bristol Bay sockeye returning in 2021. But again, all these species and other regions, Chinook declined 33% in 2021. Chum declined 38%, Coho 25% decline. And if you exclude Bristol Bay, sockeye still declined 27%. So for the remainder of this talk, I'm going to talk about pink salmon interactions, how we look at ways of testing this competition hypothesis. And I'll start off with the trophic cascade hypothesis, which is where we're looking at to see whether or not pink salmon cause a reduction in zooplankton, which in turn impact the abundance of phytoplankton. In other words, zooplankton and phytoplankton are the building blocks of production throughout the North Pacific. Then we'll look at the impacts of pinks on sockeye, Chinook, Coho, steelhead, Atka mackerel, and seabirds, and then finally killer whales. Okay, this is in order to test the trophic cascade hypothesis. I teamed up with Sonia Batten and Yvonne Ortiz, two oceanographers. Sonia is from Department of Fisheries and Oceans, or not actually, a Canadian scientist, and Yvonne Ortiz is with NOAA Fisheries and the University of Washington. But Sonia runs the Continuous Plankton Recorder program, or at least did. And it's kind of a neat program. They tow these plankton recorders shown here behind commercial vessels, and they cross the Bering Sea as shown in the tracks here. And this time period of analysis ranges from year 2000 through 2014. And the primary pink salmon population in this region, based on tagging data, originates from eastern Kamchatka. And they're a highly abundant stock of pink salmon. In recent years, past 20 years or so, they've averaged about 155 million pink salmon, returning in odd numbered years, but only about 38 million in even numbered years. And so these eastern Kamchatka pink salmon overlap considerably with Bristol Bay sockeye and many other populations of salmon. So this chart shows on the top here in the brown colors, the response of zooplankton, the zooplankton abundance in each year from year 2000 through 2014. Mainly what I want you to get from this, just glancing at this plot, is that there's a up, down pattern of abundance that's consistent with pink salmon abundance, which is also showing this biennial pattern. Except from this year 2013, an odd numbered year, zooplankton abundance was exceptionally high. Now, in this region of the North Pacific, pink salmon abundance is typically high in odd numbered years. So this is a very unique outlier that we wanted to look at more carefully. But as I showed in the previous graph, it was also the year that pink salmon abundance in eastern Kamchatka collapsed. So that was one of the first lines of evidence for this trophic cascade hypothesis. We see this biennial pattern of abundance of zooplankton, except for the 1 year that eastern Kamchatka pink salmon collapsed, in an odd year, and we see this resurgence in zooplankton. Just opposite of zooplankton, which are eaten by pink salmon, we see in odd numbered years zooplankton, which are eaten by the phytoplankton here in the green, which are eaten by zooplankton, have the opposite pattern. So we see pink salmon crop down zooplankton, which allows phytoplankton to respond. We can also correlate zooplankton abundance with pink salmon abundance, the dominant stock in this region. There's a negative correlation between pink salmon and zooplankton, and a positive correlation between pink salmon and phytoplankton. All right, let's move on now to salmon. Bristol Bay sockeye, we have quite a bit of evidence of how pink salmon impact Bristol Bay sockeye, which is kind of unique because Bristol Bay has been doing quite well in recent years. But in order to see this effect, you need to tease apart the data, because what happens in Bristol Bay sockeye, there's relatively few pink salmon in the Western Alaska, including the Bristol Bay region. And so using scale pattern analysis, we can see that there's no effect of pink salmon on the growth of Bristol Bay sockeye. But we also found that in relation to the 1977 ocean regime shift, when sockeye abundance in Bristol Bay began to double, that early marine growth in that first year at sea really took off. And so that's what we think is going on now in these recent years, that conditions with the warming ocean conditions are quite good for Bristol Bay sockeye. They're in the sweet spot, so to speak. And so they're growing exceptionally well in their first year at sea when there's relatively little interaction. But still, in their second year at sea and the sockeye's third year at sea, they still interact with highly abundant pink salmon. So that's what these graphs show. And the top graph shows the relationship between the scale growth of Bristol Bay sockeye in relation to pink salmon abundance down here, and a very strong correlation also in the third year at sea, the scale growth of Bristol Bay sockeye in the third year at sea. So we also can show the biennial pattern in the scale growth of Bristol Bay sockeye that mimics the pattern of pink salmon abundance that they interact with. Here again, this is based on scale pattern, scale growth measurements from 1965 through, this is about 2009 or so for each one of the Bristol Bay stocks. Here's Egagik at the top, Ugashik, Queechak, Naknek, Wood River. The patterns are all the same. In odd numbered years, when pink salmon are highly abundant in the ocean during the sockeye's second year at sea and third year at sea over here to the right, the growth is below average, as shown in these black bars. In even numbered years, when there's relatively few pink salmon, scale growth is relatively high. In more recent years, we've analyzed the scale growth of sockeye from Chignik, Kenai, Copper, Southeast Alaska stocks, and the Fraser River. And they all show these biennial patterns related to pink salmon. A few years ago, I also looked at the forecast error of Bristol Bay sockeye salmon in relation to pink salmon, looking for these biennial patterns. The forecasts that I used were the ADF&G forecasts. And what you see is this: in even numbered years, the forecasts tend to be too high. And the reason for that is that the Bristol Bay sockeye interact with pinks, odd year pinks, highly abundant pinks in the previous odd numbered year. And through our scale pattern analysis, we can show that there's no interaction between Bristol Bay sockeye and pink salmon during their homeward migration year. So this year, 2022, is an even numbered year. So we would expect that the preseason forecast is too high. This is, as you probably know, ADF&G has forecasted an exceptionally large run a Bristol Bay for sockeye, 75 million. And looking at this analysis, my last year of this analysis that was published was 2010. So I haven't looked at it in more recent years, but it would suggest that this year's forecast is too high. Okay, a few years ago, several colleagues and I published a paper looking at sockeye populations and the effects of competition and climate on how those factors impact the survival of sockeye salmon throughout the North Pacific. So this study involved roughly 90% of all sockeye salmon in North America, from the Fraser River down here through Southeast Alaska, Central Alaska, out west, Kodiak, Chignik, and then also into Bristol Bay. And in short, what we found, again, in this study, we're looking at both the effects of sea surface temperature and pink salmon abundance. And this data set goes back to roughly 1976, which corresponds with the 76-77 ocean regime shift through the 2009 brood year. What we found for the Bering Sea or Bristol Bay stocks is that a 1.5 degree centigrade increase in sea surface temperature led to a 23% increase in survival of Bering Sea sockeye, a 9% increase in survival of Gulf of Alaska sockeye, but actually a decrease, a 12% decrease in BC and Southeast Alaska sockeye, At the same time, in the model that we developed, statistical model, we found that the Bristol Bay sockeye or Bering Sea sockeye declined 9%, as did Gulf of Alaska sockeye, with an increase over the mean abundance of pink salmon of 119 million pink salmon. But for British Columbia and Southeast Alaska, an increase of 119 million pink salmon led to a 21% decline in the survival of those sockeye returning to British Columbia, including the Fraser and Southeast Alaska. So this analysis, I should point out, does not include the more recent rain heat wave years. It would be interesting to take a look at that as well. In this analysis, we could also tease out the effect of hatchery pink salmon, which roughly during this time period, 82 million hatchery pinks returning. And that indicated, for example, a 5-6% decline in the survival of Bristol Bay and Gulf of Alaska sockeye salmon in relation to hatchery pink salmon, but a 15% decline in the survival of, for example, Fraser River sockeye salmon. Okay, I'm sure you guys are interested in Chinook salmon, so we'll look at some evidence for the effects of pink salmon on Chinook. I gave this talk last year to people on the Columbia River, and so I want to show you this slide, in part because I want to emphasize, salmon in the ocean migrate thousands of miles, and so at sea, and so they have the opportunity to interact with stocks of salmon. They're very distant from their origin. This chart, just to show you from this genetic work that was done 10 years ago now, that here in the southeastern Bering Sea, roughly 11 to 38% of the Chinook captured in this area were from the Pacific Northwest, including the Columbia River. Just to show you, there's a lot of those fish, some of them are ESA listed Chinook salmon, are migrating tremendous distances and have the opportunity to interact with much more abundant pink salmon that are originating from Alaska and Russia. So one of the more comprehensive data sets collected on the high seas for salmon was connected by Nancy Davis, who used to be with the High Seas Salmon Group at the University of Washington. She collected salmon diet data over a 10-year time period in the Bering Sea. And that's what I just want to show the degree of diet overlap between Chinook salmon and pink salmon, because people generally think, pinks are just feeding on zooplankton, and so they don't directly compete with Chinook salmon. But that's not necessarily the case. It does vary quite a bit from one region to the next. In this chart from Nancy's data, summarized over the 10-year time period, you can see in red is the diet of squid and Chinook salmon, but you can also see there's quite a bit of squid, the same squid species eaten by pink salmon in the same area. Pink salmon are also feeding on fish, as shown here, and fish shown here by Chinook salmon. These are pink salmon that are in their second season in the ocean. So they're not the young of the year pinks, but following their first winter, they're eating, as they grow bigger, they're eating more and more fish and squid. As soon as they can start, they're large enough to capture and consume those prey. But look at the difference in odd numbered years versus even numbered years. That's the other interesting part of Nancy's data set, is that in odd years, when pinks are exceptionally abundant, the stomach contents of Chinook salmon and pink salmon are relatively low compared to even years when pink salmon are much less abundant. In fact, the decline in stomach contents of the Chinook salmon is much greater than the decline in the stomach contents of pink salmon in those odd-numbered years. Okay, this is a paper I published many years ago now, back in 2004, where we analyzed the survival of Chinook salmon released from hatcheries in the Salish Sea, Puget Sound, back some number of years ago. And it's based on, we analyzed about 50 million, over 50 million Cote d'Ivoire tagged salmon released. So these are the different hatcheries, 10 different hatcheries in the Puget Sound region. This is the survival rate shown in odd numbered years and in red years. These are the years of release compared with even numbered years. And what you see in even numbered years when they release these Chinook, they have experienced about a 62% lower survival than when the Chinook are released in odd numbered years. Now keep in mind that in the Puget Sound, pink salmon adults return in odd numbered years, but they're producing fry that entered the Puget Sound area in even numbered years. So there's an interaction between the juvenile Chinook, which are following the emergence of pink salmon fry into the Puget Sound region, leading to this decline in the survival of all of these hatchery Chinook. We also looked at the scale pattern growth of Skagit Chinook, and we found that in even years, when there's lots of juvenile pink salmon, there was reduced scale growth. More recently, there's some studies that generally support this view of interaction between pink salmon and Chinook salmon by Department of Fish and Wildlife scientists. Now we can take a more global look at pink salmon and Chinook salmon. This is just an amazing plot of data. I wanted to share it with you. So the upper left-hand plot shows the Chinook salmon commercial catch in Alaska, but excluding Southeast. I excluded Southeast because a lot of those Southeastern Chinook are headed south into British Columbia and into the Pacific Northwest. What you see is that Chinook salmon catch, this is from 1980 through 2021, declined steadily with the increasing abundance of pink salmon. Now, if we look over here, we did same plot, but now we're looking at Southeast plus British Columbia commercial catch. Again, the same type of negative correlation between Chinook salmon catch in that region and pink salmon abundance. If we look at Russia, where abundance of Chinook is much less, but still we find this negative correlation between Chinook salmon catch and pink salmon abundance. Now, if we look at weight of Chinook, which is a combination of both the growth each year, but also the age composition of Chinook salmon returning into the commercial fisheries, we see that the weight of Chinook salmon is declining steadily with pink salmon abundance. A few years ago, a good friend of mine, Leon Scholl and Hal Geiger, two ADF&G scientists, published a paper, and Leon has updated his analysis, looking at how pink salmon impact the growth and survival of coho salmon returning to Southeast Alaska. In this upper right-hand corner over here, we see the strong negative correlation between the weight of coho salmon and pink salmon abundance. This time series spans about a 50-year time period. Over here to the far upper left is a relationship between the survival of coho salmon based on Cote d'Ivoire tags and pink salmon abundance. Again, a negative correlation suggesting a negative impact of pink salmon on on coho. This is some evidence indicating the effect of pink salmon on steelhead. We know from the high seas diet studies, Megan Atchison's a student at the University of Washington, published data showing diet overlap between steelhead and pink salmon. And she found that, for example, the proportion of empty stomachs was correlated with the abundance of pink salmon in her study area. But Josh Corman and Rob Bisson, two Canadian scientists, found that steelhead survival declined significantly with increasing abundance of pink salmon biomass. These are steelhead returning to the interior of the Fraser River, the Thompson River steelhead, Chilcotin River steelhead. These are very, very popular steelhead fishing rivers. And yeah. So the question is, do pink salmon affect marine fishes? Interestingly, a couple of years ago, scientists at NOAA Fisheries published this paper. The top graph, this is a study involving the growth of Atkara mackerel near the Aleutian Islands. The top graph in the black line here, this up-down pattern shows the growth of Atkara mackerel based on otolith measurements. The brown line represents the growth of, or not the growth, but the abundance of copepods in this area that the Atkara mackerel are feeding in the Aleutian Island region. You know, that, in other words, in years of high copepod abundance, the growth is fairly good in Atkara mackerel. The bottom chart also shows the growth of Atkara mackerel in the black line. The pink line here, odd color, is pink salmon abundance. And it shows the up-down pattern, but just the opposite. So in years when pink salmon abundance is high, Atkara growth based on otolith counts is quite low. Colleagues Alan Springer, who's now retired emeritus from University of Alaska at Fairbanks, and Gus Van Vliet and colleagues published a paper looking at the effects of pink salmon on seabird reproduction. This is just scratching the surface of their paper, but again, just to show you that the hatch dates of these seabirds in the Aleutian Island region shows a strong biennial pattern that they related to pink salmon. These birds are feeding on a lot of the same plankton that pink salmon are feeding. They also published another paper showing how shearwaters that breed down on islands off of Australia are also impacted by pink salmon because they fly in their winter, our summer up here in the Northern Hemisphere, they fly up here to the Aleutian Island region and to feed, but they're being impacted by the biennial pattern of zooplankton abundance and prey abundance. And when they come back to Australia, those patterns are exhibited in the reproduction of those birds. So lastly, I wanted to just bring up a discovery that we made and published a couple of years ago with the southern resident killer whale. This is sort of a different interaction between pink salmon, we think, and the southern resident killer whale, which is an ESA listed endangered icon species here in the Salish Sea, Puget Sound region. These are the heat maps showing the distribution of the killer whales during the summer feeding season for the 3 pods. They're high, the bright red shows the high density area, basically exactly where commercial fisheries and sport fishermen are catching Chinook salmon, but also pink salmon. So the Chinook, you know, obviously they're going where the salmon are. They love to eat Chinook salmon. They do not eat pink salmon, even though millions of pink salmon are swimming right in front of them. On average in this region, 18 million pink salmon return in odd years, but only 0.4 million return in even years. Almost nothing, no pink salmon return in even years. An escapement of pink salmon in this region has increased dramatically because of conservation concerns over the commercial harvest of Chinook salmon and sockeye salmon. So what we found was that the orca's population change varied dramatically depending on odd years and even years. Over this 20-year time period in which the orca killer whale population has declined, in odd numbered years, there were essentially 32 successful births, and 17 mortalities. But in even numbered years, there were 61 deaths and only 16 successful births. There was greater or less mortality in odd numbered years, greater mortality in even numbered years. But keep in mind, these are large animals, and a previous study by a Canadian killer whale biologist found that there's roughly a 1-year lag time between the mortality of killer whales and the abundance of Chinook salmon. So we suspect that that's what's happening here. In odd numbered years, we think that the high abundance of pink salmon interferes with the foraging efficiency of the killer whales, and that this leads to eventual mortality or higher mortality in the following even numbered year. So this caught a lot of the killer whale scientists by surprise. It's still kind of an interesting topic, but there's actually a recent paper that looking at the growth and body condition of killer whales that supports what we presented here. So just summarize, and you can feel free to ask questions. Oops. Hopefully you guys can hear me. So anyways, pink salmon abundance has increased dramatically in recent years. It's just totally phenomenal. 2021, it's probably, we had over 700 million pink salmon returning from the North Pacific. Clearly they're the winners with the warming ocean that we see. We've just scratched the surface here in the presentation, but pink salmon can affect the growth, survival, and abundance of marine species. In 2020, the commercial catch of Pacific salmon declined 187 million relative to the previous 10 years. And this was a record decline. And this followed the tremendous abundance of pinks in 2018 and 19. But the commercial harvest in 2021 remained relatively low. So we continue to hypothesize that this high pink salmon abundance is impacting salmon populations throughout the North Pacific. And given all this, I haven't talked too much about some of the pink salmon or hatchery papers involving pink salmon and chum salmon, partly because they're more difficult to present graphically to you. But given this information, you have to wonder why hatcheries continue to produce so many hatchery pink salmon, given their super high abundance in recent years. You guys have been pretty quiet. So do you have any questions or?
Yeah, Virgil?
Do I need to go over here by the speaker, the mic?
Greg, can you hear me?
A little bit. It's a little bit muffled, but.
Okay, my name is Virgil Umfenauer. I just finished a 6-day meeting. I'm a member of the Yukon River Panel, which is a treaty between the United States and Canada for the Yukon River. I've been on that since 1988. Our Chinook salmon this past year, 2021, the Chena River right here in Fairbanks, the South River, 40 more miles up the Tanana, the We had perfect counting conditions. We only had 22% of the average number of Chinook salmon get counted. On chum salmon for the summer fishery, our average run is right at 2 million or a little more. We had 152,000 is all. Fall chum salmon, our average is right at 1 million. We had 102,000. Coho salmon, our average is about 250,000. We had 37,000. And one of our scientists, she gave a presentation yesterday, Katie Howard, who's doing research in the marine environment with NOAA. She has a hypothesis that potentially, because of the low productivity and the competition in the marine environment for groceries, that part of our salmon, especially the Chinook, because our closest spawning ground, or our spawning grounds like the ones that for the two largest rivers that produce Chinook salmon is over 1,000 miles. And then of course, the furthest ones are all the way to British Columbia, 2,000 miles. And our chum salmon run for our, especially our fall chums and the summer chums too, come up the Tanana River, which is one of the biggest producers. And so all those fish go over 1,000 miles. So she thinks that potentially they're not getting enough nutrients in the marine environment to get the fat content. And so they're either dying on the way, or once they get up and actually spawn, they didn't have enough nutrients to be in the eggs, so that after the eggs hatch, there's not enough nutrients in the yolk, and maybe the fish just don't die or don't make it, they just die. So my main question is, I've been bitching about this because I served 3 terms on the Board of Fish about the hatcheries for 25 years now. And so my question is, do you think that all these pink salmon out there are actually affecting the chum salmon population? I've read Geiger's study, and I've read your report that you gave today previously, but I know that they're saying they directly impact the coho and the Chinook, but what about the chum?
Yeah, I suspect they're impacting the chum too. So chum, and I didn't talk about them too much. They're incredibly abundant as well, especially hatchery chum from Japan and Southeast Alaska. The chum diet it's quite unique. So they are eating mostly zooplankton. But what we also know is that in odd-numbered years, when pinks are very abundant, the diet of chum switches to more of the jellies. They have a specialized stomach that allows them to eat jellyfish and get some level of nutrients from those jellies when pink salmon crop down zooplankton that chum would normally prefer. But we've looked at interactions between pinks and chum, and in some cases we find negative interactions. In other cases, it's not so obvious. But overall, I suspect that pink salmon do impact chum salmon. Japanese scientists a while back, they published a paper indicating to them how that in odd-numbered years, when pinks are highly abundant, for example, in the Bering Sea, that causes chum salmon to shift out of the Bering Sea and into the Gulf of Alaska. So the distribution shifts. So in other words, chum are trying their best in a way to avoid pink salmon, partly through their specialized stomach and eating jellies, but also shifting their distribution in the ocean. The bottom line is, I think probably pinks are impacting those chum.
Thank you. When I was a kid, I used to go spend summers on the farm with my grandparents and my uncles that were farmers. And all the farmers, and I grew up in Arizona, and the ranchers, they know how many prairie dogs it takes, how many jackrabbits it takes to eat as much grass as a cow. And that if there's a drought, you can't have as many animals on the range. And I don't know why these hatchery people have their head up their rectum and can't understand that, because they put more fish out there in the marine pasture whenever productivity goes down, the opposite. Anyway, that's my opinion, but
Yeah, so
we have a heck of a battle in Alaska over this, and I know that Alaska has been dumping in close to 2 billion hatchery fish a year, most of them chums and pinks. And we just have a gigantic political battle here. And
yeah,
thank you very much. I really liked your presentation.
yeah, thanks. So just related to that, Japan, which is the largest producer of hatchery salmon in the world, largely chum, they recognized through their scientific work several decades ago that their hatchery chum were coming back smaller and smaller. Their scales actually had holes in the middle of them because of some starvation. And so rather than continuing to ramp up more and more hatchery production, they actually scaled back a little bit. They still are exceptionally high abundance. But that's one example where they recognized there was a problem with releasing too many hatchery chum. Russia, on the other hand, they continue to ramp up, especially chum production. And I think they are going to just keep ramping it up until they see some sort of obvious negative impact. But you have to wonder, with the tremendous abundance of pink salmon that we're seeing, and the negative impacts on all these other marine species, why do we continue to release so many?
Yep. Kind of running out of time on Gary. A question I'd like to ask is that I'm hearing more and more, a lot from the producers and commercial fishermen and Department of Fish and Game biologists, that the issue is more on climate change. Well, I look at the data that you presented here, and I've read through it, and I've read reports from Finland and also from Japan, that shows that there's over a decade of knowledge of what's happening with the excessive number of pinks and chums, their effect on Chinook and all. How best can we get that message across that there's more to this than just global warming?
Yeah, it's a good question. That's why I offered to give a talk to you guys, just to share research findings on this impact. I think, we continue to analyze these data. I'm summarizing a lot of the data on the pink salmon effects, really on species in the North Pacific, an ecosystem level effect of pink salmon. And it's just, a way of, we just need to educate people on this. Obviously, with the warming ocean and these more frequent heat waves, they have an impact on what's going on out there. And part of that impact is pink salmon are responding. As young fish, they're eating small zooplankton and they're growing exceptionally well. But especially, I think, in their second year after their first winter, in their second growing season, they're larger and they have the opportunity to eat a lot more of that same prey that some of our key species like Chinook, coho, sockeye salmon like to eat. And so they can impact those species in what I sort of call late marine life. That is after their first year. Sort of the conventional wisdom of salmon scientists is that the main mortality of salmon occurs during their first year at sea. And there's no doubt that that's an important year or time period, but a lot of our research also indicates that these later years, second and third years at sea, are very important. And you can see it in the data, it's just really obvious. If you look at the survival of Chinook salmon from release to return. You know, Chinook are one of the older species, number of years in the ocean. They have very, very low survival. In the Saley Sea, it's like 0.5% of the Chinook that are released. And it's partly because they're spending more years at the ocean, in the ocean compared to other species like pinks and that. So, yeah, so I think just educating people.
All right, thank you, Joe.
We got
I
a
see
question.
the Department of Fish and Game at least is put together now a salmon ocean ecology program. So if they spend 20 years researching that as they did the straying, I mean, how many Chinook are going to be left after 20 years study of the confirmed competition food?
Yeah, you know, the Chinook situation is, I work in the Columbia. Most of my work has actually been in Alaska, but I'm on science panels in the Columbia Basin. And I tell people in the Columbia Basin, you know, the Chinook are declining everywhere. You know, Alaska, where your habitat is relatively pristine. So there's clearly a marine problem, not just freshwater habitat destruction. And what you mentioned earlier, Katie Howard's work and others, you know, I have no doubt that the marine environment's important because of the impact on growth and survival. But as I think you alluded to, the other, and I've written papers on this too, that the smaller size of the Chinook that are coming back, they're coming back at a younger age and smaller size at age. That's critical to those females because smaller Chinook carry smaller and fewer eggs. And so that impacts, even if they survive to reproduce up there in the Yukon, they're producing fewer juvenile Chinook because they're smaller and younger. And I think, here's another thing that, you know, I published papers on this through the AYK-SSI years ago, that you know, female Chinook spend more years in the ocean than males. They tend to come back as after 4 winters in the ocean. And so they're impacted, I think, more by pink salmon than, for example, male Chinook salmon. But it's really, we need more females coming back than the males, obviously.
Greg, we got a question here in the room. Go ahead.
Yeah, this is Bill Iverson. I had a discussion several years ago with Doug Vincent Lang concerning the pink salmon, in my opinion, overstocking of hatchery fish in the oceans. And his excuse when he came back to me was that he said that the amount of fish that we stock is so insignificant as to what is happening across the world that it's not important. And my comment back was, well, those fish don't generally come back into our rivers and impact our areas. So I didn't like the answer, and I'm not sure. Have you ever shown him this whole presentation?
No, I haven't, and he needs to be educated, I would say.
We have a person online that would like to ask a question.
Sure.
Yeah, hi, Greg. This is Gail Vick. How are you?
Oh, good. Yeah.
As you know, I participated a few years ago in that study for NCs on the salmon size decline. And one of the problems that we had was illustrating the decline in terms of poundage, not just in numbers. So what we're seeing, even in Bristol Bay, we're seeing amazing numbers come back, but the size has declined so much on average. So the question I have, I think for a lot of people, it would be a great illustration to show not only the decline in abundance, but the decline in average size over the years.
Well, so, you know, most of our evidence is on the impact of competition or pink salmon abundance on the size and growth. It's actually much harder to show the effect on abundance and survival, partly because we don't have as much survival data. But for example, Bristol Bay sockeye, you know, I work in Bristol Bay for years. I used to be the project leader of the Alaska Salmon Program at the University of Washington. I forecasted Bristol Bay sockeye for many years with Don Rogers, but we published a paper, the first pink salmon paper in 2003, where we had a data set on the size and age of Bristol Bay sockeye salmon from 1958, when Don Rogers started his work in Bristol Bay, through 2000 or so, showing the strong effect of the combined effect of Bristol Bay sockeye abundance on the size and age of Bristol Bay sockeye, but also part of that model was the effect of pink salmon on the size of Bristol Bay sockeye. And we updated that analysis in more recent papers as well. So there's actually a fair bit of information on the effects of pink salmon on the size and age. I mean, I just presented you some Chinook data here.
Ricky, did you have a question?
Hey, Greg, this is Ricky Geese. I'm currently the director of state parks in Alaska, but I've been interested in fisheries for a while, as you know. Could you just touch base a little bit? One of the other factors that I thought was really interesting in past conversations with you is as food becomes scarcer in the ocean from potentially food competition like you've demonstrated here, can you talk just, I know it's a big topic, but just touch a little bit about the impacts on differential survival rates of males and females? Because I know there's information on that for cohos, for Chinook, and other species in the ocean.
So that's an interesting question. I guess the way I'll answer it, and this gets back to studies that we published related to AYK, Chinook salmon, for example. And it gets back to this relationship that we've found, and other people I think have talked about it a bit, and that is that females spend more years in the ocean than male Chinook salmon. And that makes sense because, you know, females need to grow to a larger size so that they can bring back more bigger eggs. Whereas males can come back and spawn and sneak spawn and so forth at a younger age. And because they're spending more time in the ocean, the females, more years at sea on average, and because they're interacting more and more with pink salmon, a higher abundance of pink salmon, I think that's contributed to higher mortality of those pink females. And you know, in our reports, we showed that there's actually the return of females to the AYK region is quite a bit less than you would expect based on, you know, if there's equal numbers of males and females being produced. Brendan Connors and I tried to get funding from AYK region to further investigate this. Gosh, probably 5 or 6 years ago, but for 2 years in a row, we were not funded to continue to evaluate that relationship.
All right, is anybody else got any more questions? I think we're kind of running down on time here. Nope, all right.
Greg, thank you so much for your time, and we'll stay in touch.
Okay.
Educating the public is going to be necessary to do quicker than 20 years.
Yeah, no, you know, people talk about the ocean as being a black box. There's a lot we don't know, but there's also a lot that we do know. And so people need to start paying attention.